Hi everybody, today we'll be talking about acid and bases, a continuation of our previous chapter, chapter of water, solution and suspension. So under this particular segment, we will first be describing acidity, neutrality and alkalinity based on the pH scale. So the pH scales are basically a set of numerical numbers that will allow us to tell us whether a particular solution is it acidic, is it neutral, or is it very alkaline. You will also need to know how do we actually detect that these are the individual parts based on the color from the indicator that tells you the color of the different substances with respect to their pH, and of course to investigate how these conditions of the solutions actually react with the indicator. Okay, so substances, right, can exist in two to three main kinds of classification. They are either acids or alkali. There is only one that is under the neutral, in which both are solutions. So how do you know that a solution is acidic? There are a few properties. For example, number one, the acids must have a sour taste. So this sour taste is one particular characteristic for the solution, but please do not go to the science lab and then drink acid. Acid in that sense is like these chemicals are actually quite poisonous and corrosive. Now what are the other more safer kinds of acids? They are actually found, they are in a way like your organic acids, which are found maybe in fruits. One example is citric acid that's found in maybe apple or oranges, where even in lemon, when you taste it's very sour, so that is actually a form of the acid that is actually reacting. But of course not everything that is sour is acid. Okay, it's just this is the kind of taste. So some examples of household items that contain acids are like a lemon juice and vinegar. Okay, next, what about alkali? Alkalis are generally bitter in taste, and they belong to a larger group of chemicals known as base. What this means is actually base is a very big family of solution, and a subset of base, right? One part of base is what we call alkalis. Now, why is so special about alkalis and what's so special about base? Alkalis are basically bases that are soluble in water. That means right, when you put into water, it is able to dissolve in water. Okay, so that's the main gist of alkalis. And where can you find alkalis? You can find them mainly in detergents and baking powder. Okay, so because some of the solutions are like colorless or maybe green color or in a wide range of color, and it's very hard to tell whether is it an acid or alkali even before you tasting it. Of course there are some chemicals that are quite poisonous. You don't go and taste to say this is sour and this is an acid. So what is one easier way is we use indicators, which when we act with the solution, they are able to produce most probably a color change or a color observation that will indicate to us whether is it acidic or alkaline. So two main indicators we'll be exploring is number one, the litmus paper, and number two, the universal indicator. So the litmus paper is just one piece of paper. There is two main types. There's the red color and the blue color litmus paper. It's just let's say it's a red small red slip of paper. When you put it onto the solution, it will be able to change color or it will remain the same. If let's say there is to indicate is it an acid or alkaline. A universal indicator is like a solution so you drop it into maybe a few of the acid or base solution, you will see that there is a color change, and this color change is quite wide. It can go from red, orange, green, purple, blue, to indicate whether is it acidic, neutral or alkaline. So in this case, over here we look at the litmus paper. So this is an example of a blue litmus paper, and you can see it actually change to red or turns red. Now why does it turn red? Is because you place it in an acid. Same thing, if let's say you use a red litmus paper when you put it into a solution that is alkali, okay, this red litmus paper will change to blue color, okay, because it's an alkali. Now let's change it a bit. What happens if you put in a red litmus paper? If you put a red litmus paper, there will not be any color change. It will still remain red. Why? Because it's an acid. Likewise, if you put a blue litmus paper here, it will still remain blue. Why? Because it's an alkali. So one way to remember is whatever color of the litmus paper, the end color, right, for acid is always red in color, and the end color for alkali is always blue in color. Okay, for the litmus paper. What about universal indicator? The universal indicator is a solution where after you have placed it into the solution of an unknown solution, these colors would actually tell you, these spectrums of colors will be able to tell you what is it like, what is the pH like. So what we can see is this is mainly for pH 1, pH value 2, pH value 3, 4, 5, 6, 7, 8, 9. Oh, they actually have a change in color, sorry. So it's 1, 2, 3. Then I believe there's no 4. There's a 5 here, there's a 6, 7, 8, 9, 10, 12, and 14. Okay, I'm not sure why they skip, but generally it's like this. Now, what is pH value then? pH value indicates the concentration of hydrogen ions in the solution. Now this one is a bit quite technical at your level now, but what is H plus ions? These are the ones. Just imagine an acid solution, right? When you put it into water, you dissolve into water, it will release the H plus ions. So what will happen is pH value is a measurement of how much H plus ions are there in the solution. Okay, so of course the higher the concentration of H plus ions, the lower the pH value. That means the more acidic it is. So until here, it is acidic. Okay. Number 7 is a miracle mark for neutral, and anything here would be alkali. Okay, over here. So as you can see, acid is again red in color. Then it changes to become more greenish in color. I'm actually not sure why is it quite green at number 10, but generally it tends to be quite green at the neutral area. Then alkali, it will be more violet or purple. So this is the color chart that you have to memorize. As in exam, they tend to test you what is the color. Just remember that acid, right, tends to be red in color. Alkali tends to be violet in color. Violet is like purple in color, and in between is green in color for neutral. Okay. You are also required to remember some of the examples of the individual pH value in case the examination they ask, or they will ask you, okay, banana, what is the universal indicator like? So you must say like somewhere about maybe green or pH 5, or it's actually acidic. Not the banana, but the acid that's present in the banana. Okay, so these are generally how we can see that the lower the pH value, the more acidic it is, and the higher the pH value, the more alkaline it is. The only number you have to remember that is always constant for neutral is at number 7. So the big number 7 is only for neutral. Anything below 7 is acidic, anything above 7 is alkaline. Your number will also stop until 14. You will not go anything more than 14, neither will you get a negative number. Okay, so the range is only from 0 to 14. So like what we have actually explained, acids will actually have a pH value that is less than 7, while alkaline have a pH value of greater than 7. A solution of pH value of 7 is usually described as neutral, meaning it is not an acid or a base. Okay, so just to recap what we have done, We have already we know that solutions can be classified into either acid or alkali, or in a way one more is neutral. So for acids, how do we tell that a solution is acidic? There is two ways. We use indicator, either a litmus paper or a pH indicator. So for litmus paper, if we use a moist red litmus paper and you dip it into a solution that is acidic, it will actually remain red. However, if you take the red litmus paper, you put it into an alkali solution, the red litmus paper will turn blue. Litmus paper, if you use a blue one, you put a moist blue litmus paper, you put it in acid, it will actually change to red color. And likewise, for a moist blue litmus paper, when you put into an alkali solution, it will remain blue. For pH values, we know that it ranges from 0 to 14, where number 7 is for neutral. Anything less than 7 in terms of pH value is acidic. Any value that is more than 7 is alkaline. One way to also show it more, to make it more specific, is to actually use a pH indicator, a universal indicator, where it changes color based on its number value. So we can see that the more acidic it is, the more red in color it is. If it's pH 3, it will be more orange, and for pH 7, it will be green in color. pH 10 will be bluish in color, and pH 14, it will be violet in color. So the universal indicator is actually a more accurate indicator as compared to litmus paper, as the litmus paper can only tell 2 color change. However, the universal indicator can give you a spectrum of color, and you have to remember the color range. Okay, so one other property of acid other than just the color is the taste, in which it has a sour taste, whereas for an alkali, it has a bitter taste. As you go up to upper secondary, you also start to understand more as to what are the chemical reactions for an acid and what are some of the chemical reactions for an alkali. But for lower secondary, this is not really required. If you want to read up more, please go and read your textbook. They give very good explanations, and hopefully this will help you in your studies. Do remember to subscribe to my channel, like my video, and stay tuned for the next lesson chapter. If there's nothing else, that's all for this chapter. Thank you and have a nice day.